Okay, so we want to test the claim that the mean is equal to 60 seconds. So mean equals 60 seconds, and this happens to be what we're claiming. Alternatively, it doesn't equal 60 seconds. Okie dokie. Time for the test stat. So we're only dealing with one population here, and so we're talking about means, and they happen to give us the standard deviation of the population. They say assume sigma equals. So we're using a z instead of a t, and it's going to be the score we're interested in. So our sample was 58.3, and that's different from the 60, but not so much. How much is, you have to determine how many standard deviations. So over the standard deviation, which was, assuming sigma equals 9.5, divided by the square root of the sample size, that was 40 students. And we pop this all in our calculator, being careful to put parentheses on the top and on the bottom, and we get that our z is negative 1.13. So our score was only 1.13 less than than what we're claiming. It's not too far away. But how do we determine if that's significant? We can use either critical values or p-values. So a critical value, because this is a not equal to, it's a two-tailed test. And they say it's a significance level of 0.05. So you go 0.05, two-tailed, and since it's a z, take it all the way down, and you'll get negative 1.96 and positive 1.96. And so our test stat is negative 1.13, so that does not fall in one of those rejection regions. It was not extreme enough to say that that null hypothesis wasn't right. So we fail to reject the null hypothesis, which means there's not enough evidence to, and since our claim was the null, there's not enough evidence to reject our claim. It seems like this middle guy is right. It seems like the mean time is approximately 60 seconds. Our value was not extreme enough to reject it, so yay for our claim, about 60 seconds. So the official wording from the magic sentence is there is not sufficient evidence to reject the claim. If we wanted to do p-value method, at this point here at step 3, instead of taking these arbitrary critical values, we would put our test statistic straight on to our z-table, look this up on our z-table, and trace it over to find a probability, which would be 0.2584, which means like 25% is captured in there, which is big. So this is not less than alpha, so we fail to reject the null and have the same conclusion. That's it.